worked example 3 has y equals e to the negative 5x. So we've got a function up here. So what I'm going to do is I'm going to use the chain rule. So I've written it over here just to remind you. So dy dx equals dy du times du dx. And I'm going to let u equal what's in the exponent up there, negative 5x. So now that means I've got y equals e to the u. So that kind of looks nice. I kind of feel like I'll be able to differentiate that really nicely. Now remember, when we use the chain rule, we need to differentiate y with respect to u, and we need to differentiate u with respect to x. So the dy du, this part over here, that is me differentiating y with respect to u. So that is this line. And then I need to differentiate u with respect to x, and that is going to refer to the information in this line. So I'm going to go ahead and do those things straight away. So dy du. Well, I'm looking at this equation, and I have just learnt that when I differentiate an exponent, it actually stays the same thing. So dy du is just going to be e to the u. And then when I look at the next bit, and I want to find du dx, so I'm going up here to this equation. So du dx, so when I differentiate negative 5x, I get the answer negative 5. Okay, because the x to the power of 1 reduces by 1, so it becomes x to the power of 0, which is 1. 1 times negative 5 is negative 5. So now I can just put all those things together in my chain rule to find my gradient. So let's do that. So dy dx is going to equal dy du. Dy du is right here. That's e to the u. I'm going to multiply that by negative 5. Now normally, of course, we write our numbers in front, so I'm going to put the negative 5 in here. E to the, now I'm not going to write u anymore, but I'm going to put what I said u was back up into the equation, so negative 5x. And there is my answer for the derivative, finding the derivative of e to the negative 5x.